Hi Chem fans, and welcome back to another Chemistry the Right Way 15-minute tutorial. Today we're talking more about nomenclature, or as they say in the colonies, nomenclature. But it's important that you understand that chemists talk to each other with a very, very specific vocabulary, and there's no way around it. Unfortunately, you just have to learn that vocabulary. Now, when I teach this, I always try to tell my students, I can't read music. Okay, but those of you that can understand that those little dots and lines and the bars and the staff and the time signature all have very, very specific meanings, and those of you who can read music can see through the page and into the very sort of the tunes and the melodies and the sounds that they make. I can't read music, but I can speak chemistry. And for that, you need to get to grips with certain vocabulary. So today we're talking all about polyatomic ions, and let's break that down for a start out. So, three different terms there. So poly meaning many, atomic meaning atoms, and then ions meaning charged. So what we're talking about is a cluster or a group of atoms that together take on one single charge, or what we call oxidation state. Now, the good news is that the vast majority of polyatomic ions are anions. That means that they're negatively charged, okay? So we're really talking about, there are only a few polyatomic cations. They're very important, but there are only a small number of them. Anyway, let's go into how we name them and then understand kind of what it means in terms of their structure. So, one of the pieces is most polyatomic ions are made up of a sort of a central or a theme atom. Okay, I'm just going to go that far. It's not super specific, I understand that. But then that central themed atom is then combined with normally just a small number of different atoms, predominantly oxygen. Okay, so for instance, here on planet Earth, we have a lot of oxygen in our atmosphere. About 21% of the atmosphere is oxygen here, and the lower levels of the atmosphere certainly. But there's actually a heck of a lot more oxygen in other places, like, for instance, seawater, as in water, as in H2O. There's a lot of oxygen there. But there's also a lot of oxygen trapped, not sort of within the rocks of the Earth, the rocks and the minerals, but rather combined to make rocks and minerals. So the group that we have that contains oxygen, and then underneath it sulfur, very, very important. And then going on to selenium and tellurium. Okay, but it's these guys that effectively give us our group name. Okay, so group 16, oxygen, sulfur, selenium, tellurium. These guys are known as the chalcogens. And chalcogens means ore forming. Ore, as in iron ore, lead ore, copper ore, the actual rocks that contain the chemical that you're really looking for, like iron. Okay, so iron ore is actually made up of iron, and then some amount of predominantly oxygen, and then sulfur, and then other trace substances as well. Let's stay on track. What we mean is the vast majority of elements will combine very, very readily with oxygen or with sulfur. And as chemists, we name that process, right? So back to our polyatomic ions. Okay? And there are a whole group of these, but they've just got these like sort of theme notes that go with it. First of all, it's all about the suffixes. And the suffix that you are super common with, if you've done any chemistry at all, or even heard sort of chemical terms, or looked on the back of a bottle of vitamins or whatever it would be, is the suffix ate. A-T-E, right? That's incredibly common. We can talk about sulfates, phosphates, nitrates, carbonates. We can talk about chromates, we can talk about dichromates, we can talk about molybdenates, zincates, etc., etc., etc. It's always got this suffix, this term, ate, A-T-E. That has meaning. So in chemistry, if something ends in ate, this means presence of oxygen. Now, again, super unfortunate. This does not mean how much oxygen, how many oxygen, or the overall charge on the ion. You've got to memorize it. But you do know this. If it ends in ate, it means there's oxygen involved. So let's just take a look at some common ideas there, okay? So some common ideas. What we're going to do is we're going to take a theme atom, and we're going to form a polyatomic ion and see how its name shifts from that, right? So we'll start out with a very common one, very easy one, and we'll start out with nitrogen readily bonds with oxygen to form a polyatomic ion. So nitrogen combines with oxygen. So the name we get from that is nitrate. And then from the oxygen, ate. Okay? Nitrate. That's it. Doesn't tell you how much oxygen, it doesn't tell you the charge on the overall polyatomic ion. That's the bit that has to be memorized. Nitrogen, N, symbol for nitrogen. Oxygen, O. It just so happens to form a stable group like this as a polyatomic ion. We have NO3, and the overall charge on that ion is -1. This formula and this number, they're not mentioned in that name. That name simply says I'm negatively charged. Yes, it talks about the negative. It says it's a polyatomic anion, but it doesn't say by how much. And it doesn't tell you the formula. Unfortunately, you've got to commit that to memory. So, that's nitrate, right? What about some others? Well, if I put up the formulas, let's see if you can get the names. So, SO4, ClO3, PO4. Okay, those are the formulas that you would see in a given compound. Now, I'm going to go ahead and give you their oxidation states. That's the charges. SO4 is -2, ClO3 is -1, PO4 is -3. None of that's going to come through in the names. Unfortunately, the list of polyatomic ions that you'll get during your chemistry courses are just ones you have to commit to memory. But the naming is super easy. So, because it contains sulfur and oxygen, sulfur becomes sulfate. Chlorine and oxygen, chlorine becomes chlorate. And lastly, phosphorus. Phosphorus becomes phosphate. That's it. That's those names. It's always that. So, for instance, you know, we talked about like a chromate. You know that it contains two things. You know it contains chromium, and you know it contains oxygen. Unfortunately, you don't know how much oxygen, and unfortunately, you don't know the overall charge, but you do know it's negative. These are the ones you just have to commit to memory. okay? Unfortunately. But you'll get it. All you got to do is, you just got to try to do it. You just got to look more, do that rote memorization thing, make the flashcards do whatever. But now I'm going to show you how the name also changes certain things about it. And for that, I'm going to use this chlorate group right in the center here, because there's a little bit more to naming, and if you can grab a hold of this, it'll certainly put you one step beyond and ahead of all your chemistry colleagues who are studying at the same time as you. It's all about the meanings of things, okay? So there's a chlorate, and that ion is ClO3 -1. But what happens if we can make a polyatomic ion with various amounts of ingredients? Here I've got chlorine and oxygen. Okay? Well, I could increase the amount of chlorine. I can't decrease it. There's just one right now. I can go up or down on the amount of oxygen, and this is where the magic happens. If you can memorize the 8 form of an ion, it opens up everything else. Everything. So, all you got to do is memorize the 8 and then these rules. 8s, I'll just leave it not in plural. Ite, okay? So we're going to go ite down here, we're going to have another ite down here, we got 8, and then we've got another 8. What? Okay. There are prefixes and suffixes. So here we've got no prefix and just that simple suffix, that 8. But here's what I'm going to do. I'm going to increase the amount of oxygen by 1. Right? And now I've got a chlorate, chlorate. Right? But now its formula is ClO4. The charge stays the same. Neg1. It's the case. The oxidation state remains the same. But how do I indicate that I've got more oxygen? The answer is I use a new prefix. And that prefix is per. Okay? Perchlorate means 1 more oxygen. That per means 1 more oxygen on the ion to balance everything out. So if you know the chlorate form, the perchlorate form is just throw on an extra oxygen, just increase the oxygen by 1. It actually goes on. There are actually, get this is old chemistry, right? This is before there was the metric system. So there's actually perchlorate, then super, and then even hyper. Now these don't always work. You can't always get these formulas. It's just the old way before the metric system of kind of like indicating quantities of things. But stick to this, right? Stick to this. So you've got perchlorate. So if I go back the opposite direction, I'm going to stick with my chlorate, but now I'm going to reduce the amount of oxygen by 1. ClO2. Neg1, still got that same oxidation state. And now 8 becomes ite. Chlorite. Okay? I can reduce it to 1 more. ClO. Neg1. 1, 2, 3, 4. Chlorite becomes hypo. Not hyper, like you can be hypotonic and hypertonic in biology. Hypo is the prefix. Chlorite. Chlorite. There you go. So it goes like this. Chlorate, 1 more oxygen, perchlorate. Got a suffix and prefix. Then you can go the opposite direction. Chlorate becomes chlorite. Chlorite becomes hypochlorite. And this can happen, right? So You can have nitrates, nitrites, sulfates, sulfites. Okay? So if a nitrate is NO3 neg1 and nitrite is NO2 at neg1. If a sulfate is SO4 at neg2, then a sulfite is SO3 at neg2. If a phosphate is PO4 at neg3, a phosphite PO3 at neg3. Same thing. 8-ite, 8-ite, 8-ite. But there is one more change, okay? And that's this word or this suffix, another suffix. It's chemistry, right? You can do suffixes on suffixes. And for this, I'm going to use the sulfate ion right here. Sulfate with a pH, not an F. Okay, sulfate SO4. There's another thing that can happen because oxygen and sulfur are both chalcogens, they're both part of group 16, their chemistries are relatively similar. That's what puts them in group 16, right? That's the periodic law. Because of this, oxygen and sulfur can sometimes switch. And so what happens is we can decrease oxygen by 1, and then we can increase sulfur by 1. So in other words, we're going to take out an oxygen, SO3, and we're going to replace it with a sulfur, S2O3. And when that happens, the prefix becomes thio. So now we have a thio sulfate. Again, oxidation state remains the same. That's what a thio is. Now you can still have, like the most complicated one I give to my students in order to make sure they're understanding this, is I will give them like a thiosulfite, right? And so thiosulfite, you got to be able to do it forwards and backwards, right? So a thiosulfite, if we go from the name and we'll get to our formula, let's see how we do that. Okay, so thio means I've traded 1 oxygen for sulfur, and then sulfite means I'm 1 less oxygen than sulfate. So if I've remembered, what I've got to do is go back in memory banks and go, okay, what's a sulfate ion? What's sulfate? And I was good, and I committed those to memory. And so I know that's SO4 at -2. Now I'm going to do this. I'm going to go to the sulfite, that'll be SO3 at -2. And then I'm going to go to the thio. Drop the oxygen down by 1, O2, increase the sulfur by 1. S2O2 charge remains the same. You can only get here if you know this. So commit those polyatomic 8 ions. The nitrates, the carbonates, the phosphates, the chromates, the dichromates. Commit them to memory. Those are the ones that you need to. And the rest, just understand the rules. And you'll get there. Thanks very much. Please hit the like, subscribe, do all that stuff. More videos to come. And keep it chemistry. All right, bye.